Hello everyone, welcome back. Guys, today we are going to understand CRC, Cyclic Redundancy Check. Or you can say we are going to understand CRC error. A very important topic for network engineers. Because many network engineers are struggling to troubleshoot problem like CRC counter increasing, we are getting packet loss on interface, right? My customer are facing slowness, right? We are getting, let's say, input errors or collision, counter is increasing on interface. So how to troubleshoot these type of problem, right? Guys, the main reason of making this video is what many of my subscribers is requesting me to make one video on CRC, right? So I decided to make one video on it, and today we are going to cover multiple topics like multiple counters. Actually, I'm going to run one command, right? That command is show interface, after that interface type, and then interface ID. Let's say show interface fast ethernet 0/1. So this command is used to check description of interface, and in the output of this command you will see these all counters like CRC error, collision, input error, right? And many more counters are there. We will discuss everything. This video is going to teach you everything about layer 1 and layer 2 troubleshooting. Guys, maybe this video can be lengthy, but again, I'm telling you, you are going to learn lots of things in this video. So make sure if you are a network engineer working in industry or struggling right to troubleshoot network, watch this video till the end. Or you are among the people who want to become a network engineer, guys, this video is very important for you. Because interviewer can also ask you multiple questions from here, like let's say how to troubleshoot slowness, how to troubleshoot CRC error, why I'm getting CRC error on interface, right? What can be the reason, right? So these are interview questions. We are going to cover multiple interview questions in this video, right? Now guys, without wasting our time, let's begin. First of all, what is CRC? If you are asking me, hey Praphul, tell me a simple definition of CRC. If someone will ask me what is CRC, what should be my answer? So first of all, let me give you a small definition of CRC, right? So let me write here. You can say CRC, like cyclic redundancy check. A CRC is a error detection mechanism. It is a mechanism commonly used in network to identify data changed, or you can say corrupted, data corrupted during transmission. What I am saying, a CRC is an error detection mechanism commonly used in network to identify data changed or corrupted during the transmission, right? So let's say, let me give you a small example of it here, and we are going to discuss many more examples, right, in this video. Let's say I have two computer A, computer B. Both are connected through one Ethernet cable. Let's say computer A is sending one data to computer B, and computer B is receiving, changed data. Right? There is some change in data, or data is corrupted. Then this computer will discard the data. So how this machine is going to identify changed or corrupted? The data is changed or corrupted with the help of CRC. With the help of CRC, we will understand how, right? See, again, our concern is not how CRC is going to, run the algorithm and is going to calculate the, value. With the help of that value, it will check data is changed or not, or corrupted or not, right? That is not my concern. My concern is how we can identify the changed or corrupted data during the transmission. If there is some change or data is corrupted, I will drop it. If there is no change, not corrupted, then I will accept it. Okay, now let me move further. This is a small definition of CRC. What you can say, a CRC is an error detection mechanism commonly used in network to identify data changed or corrupted during transmission. Next thing, what you can say, when CRC, in simple word, how you can say when CRC, error will occur, right? So always keep in mind, a CRC error occurs when a device receives a Ethernet frame with a we can say CRC value in the FCS. Soon we are going to discuss Ethernet header also, right? So as you know, in Ethernet header we have three fields mainly, right? One is my actual data, then we have header, Ethernet header, and then we have trailer. So trailer is nothing but FCS, frame check sequence. So what I'm saying, a CRC error occur when a device receive a Ethernet frame with a CRC value in the FCS in the FCS field, field of the frame, that you can say what, that does not match the CRC value calculated by the device for the frame. See, read again. A CRC error occurs when a device receives an Ethernet frame with a CRC value in the FCS field of Ethernet frame that does not match the CRC value calculated by the device for the frame, right? Again, what I'm saying, again we have, let's say, two PC1, PC2, right? If PC1 is sending data to PC2, right, we will have Ethernet header at layer 2. In Ethernet header we will have three information: data, after that header, Ethernet header, and then trailer, right? This is basic structure of Ethernet header, Ethernet frame, you can say, right? And this trailer is nothing but FCS, right? Frame check sequence. So when PC1 will send data, it will perform CRC, and it will send some value, right, under this FCS field at CRC value. And machine B, computer B, is also going to calculate CRC value. If both CRC value will match, right, then only this PC will accept it. Otherwise, it will drop the data and you will see one CRC error, right? Counter will increase by 1. Means you have received one changed data or corrupted data. Getting my point? Let me give you one example here in Word. I have, some definition. Example is what? Consider a scenario where two hosts named host A and host B are connected to each other through their network interface card through NIC. Host A need to send the sentence, and sentence is what? Let's say this is an example, right, guys? I have picked this, example from the Google, right? So sentence is what? This is an example. This is my actual message, right? Host A want to send this actual information to host B over the network, right? So till here, hope everything is clear. We have two computer, host A, host B. Now host A want to send one data, and what is data? Data is, this is an example, to host B over the network. Now see, host A crafts an Ethernet frame destined to host B with a payload of, this is an example, this is my actual data, this is my payload, and calculate that the CRC value of frame is the hexadecimal value. Let's say it have calculated this CRC value. It have calculated this CRC value for this frame, for this payload, right? Now host A insert the CRC value of this is hexadecimal value, right, into the FCS field of the Ethernet frame, then transmit the Ethernet frame out of host A's NIC card. Then computer A will transmit this data from this interface, from this NIC card, correct, towards host B. First is my actual information, my payload, and actual information is, this is an example. Then devices has calculated one CRC value, and it have put that CRC value under FCS field, right? After that, it have transmitted the frame from their NIC towards host B. However, damage on the physical link media, let's say because of some damage, right, because of some issue on the physical media, right, connecting host A and host B corrupts the contents of the frame, such as the sentence within the frame changed to, this was an example. Actual payload is what? This is an example, and let's say here there is one attacker, right? They have changed the information, or there is some problem on the link. Because of that, let's say my information has changed, or some information has missed on the link, right? So now my actual payload is, this was an example, right? So what it's saying here, read again. The frame such as the sentence within the frame changed to, this was an example, instead of the desired payload of, this is an example. So what will happen in this scenario? See next point. When host B receives this frame, it will calculate CRC value. It will calculate CRC value of the frame, including corrupted payload. Host B will also calculate what? CRC value with corrupted payload. Then definitely host B will calculate different CRC value, guys, right? Different CRC value, because now payload is different. PC1 PCA have calculated CRC value with what payload? This is an example. And host B is calculating CRC value with what payload? This was an example, right? So both will calculate different CRC value. Getting my point? Now, if you want to know how this device is going to calculate CRC value, right, you can search it on YouTube. You will get video of 2 to 3 minutes, which will teach you. Okay, but as a network engineer, this is not important for you, right? Just understand this, that whenever device need to send a frame, it will calculate a CRC value with the help of payload, and then it will transmit from their NIC. When receiver machine will receive the frame, it will also calculate CRC value. It will also calculate CRC value with payload, and it will compare their CRC number, their calculated CRC number, and the CRC number which is coming inside the FCS, inside the FCS field. If both are not same, right, like in this scenario, host B calculates the CRC value of the frame is a hexadecimal value of this one. You can see this is different from the CRC value of host A. Host A have put this CRC number in the FCS, but host B is calculating different CRC value, which is different from this. This is CRC value of computer A, right? So CRC value of computer A in the Ethernet field, in the Ethernet frame. This difference in CRC value tells host B that Ethernet frame was corrupted while the frame was transmitted to host B. As a result, host B can't trust the contents of this Ethernet frame, so it will drop it. Host B will usually increment some sort of error counter on its network interface card, right? It will increment some sort of error counter on its NIC card, right? Such as input error, CRC error, or RX error counters. Right? There are many more counters we are going to discuss. So now hope this is clear to you, like when device will calculate, right, how device is going to identify data is corrupted or not, right? Let me give you same example again. Again, we have host A, host B. What I'm saying, whenever host A need to send data, let's say this time host A need to send data, and the data is, let's say 1, 2, or let's say hello. Data is what? Hello. With this data, this machine will calculate what? CRC value, and it will put that CRC value in their FCS field. Let's say CRC value is 0x123, right? And on the link, data is changed. Let's say computer B is receiving what data? Actual payload is, let's say, high, right? This is my actual payload. So this computer is receiving this payload, and with this payload we have one more field, that is FCS. Inside the FCS there is CRC code, and CRC code is 0x123. Now computer B is also going to calculate their CRC value with the help of payload. Payload is what? High. So definitely this time payload is different, so computer B will calculate different value. Let's say computer B is calculating what value? 0x, let's say 231, right? So this time you can see CRC value which is coming in the frame is different from the CRC value that host B is calculating. So this machine will came to know that this data is corrupted. So it will drop the data and it will generate one kind of counter, error counter on NIC card. Getting my point? So on the NIC card, let's say here you can see I have access of one switch. So on this switch, you can see the output of this command. So interface fast Ethernet 0/1. If I'm running this command, you can see the output. There are many outputs, and here you can see these counters, like as I told you, CRC error, 0 CRC error, right? So till now on this interface we have 0 CRC error, right? 0 input error, right? 0 collision, 0 output error. We are going to talk about each counters, don't worry, but hope this is clear to you, like what is CRC, and why we are using it. Now guys, let's move to next part. If you are getting CRC error, right, if let's say here we are able to see some CRC error, right, CRC error. So actually, mainly the 90% chances this is because of layer 1 issue, right? So you should check your cable, you should clear the counters, you should set the interface, you should run no set command again, and you should check again, right? It can be because of clocking conflict as well, because I remember in real time I was troubleshooting same issue, right? In my scenario, CRC error was increasing with input error and CRC both were increasing on the serial link, and when I troubleshoot that, there was some problem with clocking conflicts, right? So reason can be anything. There is many possibilities, right? Okay, but what I'm saying, mainly you will get CRC counters because of layer 1 issue, because of cable, not cable only, right? It can be the problem of NIC card port, right? Maybe you are using connector on the port, so you can get CRC counter because of faulty connector, because of faulty ports, or because of faulty cables. Getting my point? These are 90% chance, right? Again, we have 10%, maybe because of clocking, because of duplex, speed, right? There are many more possibilities. But in 90% cases, we are troubleshooting CRC error in real time by checking these 3 components, right? Now let's move, guys. And so guys, see, when I'm running command here, so interface type, first Ethernet, and then interface ID 0/1, right? This is output. This is output. We will read these all information, but see first counters. These are counters. So guys, sometime, not sometime, in most of the time, you will see, you know, your CRC counter is increasing, right? Your CRC counter is increasing. On the interface, the presence of many CRC error, but not many collision, right? If you have lots of CRC error, but very less number of collision, or you don't have collision, right? Collision counter is 0. You are getting only CRC error. So this type of problem is called, you know what? This type of problem is called excessive noise. Excessive noise. And how to troubleshoot excessive noise? Main troubleshooting of excessive noise is what? Check cable to determine whether any are damaged or not. Check what we can say. First check interface NIC, means you can say port. Then check connector. Check connector. If you are using connector on the port, so check connector. Then check cables. Then check cable between the devices. This is the step to troubleshoot excessive noise. And what is excessive noise? When you are getting lots of CRC error, but you are not getting collision. That type of noise is called what? Excessive noise. And to troubleshoot excessive noise, you need to check interface NIC. Then you need to check what? Connector, if you are using connector on the port, right? And then you need to check cable. Then you need to check cable. Look for bad cabling, right? Bad connector. Maybe there is some faulty in connector, or maybe there is some fault in your NIC port. Or next thing can be what? This is step 1, first step. Then you should check what? Connector, and then you should check what? Cable, right? Now let's say you have checked port NIC is working fine. You have checked the connector is also working fine. You have replaced it, but still you are getting lots of what? CRC error, but less collision, or you are not receiving any collision counter, right? That means you have checked cable also, right? Cable is also working fine, means you have replaced the cable, but still you are getting same problem. Then what you need to do? Then you should check what? Let's say, as I told you guys, for excessive noise, problem is because of layer 1 only. Problem is because of layer 1 only. So you need to troubleshoot layer 1 only, right? So what you can do now? Let's say if you are using, 100 base, you are using 100 base. Sure, if you are using 100 base TX, so make sure you are using category 5 cable, right? Not another type. Maybe you are using, category 3. Because of that also you are getting same error. You can get same error, right? Excessive noise. You can get excessive noise. Let's say you are using 100 base. You are using cat 3 cable, right? So make sure you are using what? Cat 5 cable over here. So this is troubleshooting step for excessive noise. And what is excessive noise? When I am getting lots of CRC error and we are getting very less collision, or we are not getting collision. Fine. Second type of error is excessive runs frames, right? Excessive runs frame. Guys, in a shared Ethernet, run frame are almost always caused by collision. Caused by collision only. And you know what is collision? Collision means what? Colliding something. So on a shared media, if two devices are sending, let's say we are using Ethernet to connect PC1 and PC2 together, right? So as you know, Ethernet is what? Shared media, multi-access. So if both devices will send data at the same time, and let's say it is working on half duplex, so definitely here collision will occur, right? Collision will occur over here. So that type of problem comes under runs. That type of problem come under runs. And you know, when you will get runs counter, let's say here you can see in the output we have run counters as well. Where it is? Just wait. Somewhere you can check. There will be, yes, here you can see 0 runs. So you know, minimum length of Ethernet frame should be what? Minimum length of Ethernet frame should be 64 bytes, and maximum length of Ethernet should be what? Maximum length of Ethernet should be, can be, we can say, can be 1518. So let me write here, if I will talk about the minimum length of Ethernet header. So minimum length of Ethernet header can be 64 bytes, and maximum can be 1518 bytes. So if your frame length size is less than 64 bytes, then you will get which counter? Then you will get runs counter. You will see run counters is increasing, right? That means you are receiving or you are transmitting a frame whose length is less than 64. Whose length is less than 64. Now, if we have this problem, excessive run frame, then how to troubleshoot? So as I told you, this is because of collision, right? So check the duplex. You have configured full duplex both side or not. Let's say if you have configured one side duplex and one side auto, full duplex one side and one side is auto. In that scenario also you can get, you know, this noise, excessive runs frame. So in Ethernet environment, runs frame are almost always caused by collision. If the collision rate is high, refer the problem of excessive collision. Okay, and if run frames occur when collision are not high, what I'm saying, if run frame occurs when collisions are not high or when a switched Ethernet environment, then they are the result of under runs, or you can say bad software on a network interface card. Yes, because of bad software also you can get this noise. So in this scenario, what you need to do, use a protocol analyzer to, you know, to try to determine source address of the runs frame. You can verify the source, and like that you can use this approach to troubleshoot, right? So till now we discussed two types of problem. One, if my CRC error is increasing, right, is increasing, but I'm not getting much collision. Collision counters are not increasing much. Definitely we are getting few collisions or we are not getting collision, right? That is excessive noise. And how to troubleshoot excessive noise? First we need to check the port. So port should not be faulty. Then we should check connector. Connector should not be faulty. Then we should check what? Cable. Cable should not be faulty. If these all things are fine, then we will check what? Ethernet. Like Ethernet type configuration, right? Let's say we are using 100 base cable. So definitely we will use Cat5 cable only, right? So next can be what? Next part. Now try to read the output of this command. So interface fast Ethernet 0/1, right? First information is what? This is my command. I have run this command. See, fast Ethernet 0/1 is up. This is what? This is a status of this interface. A status of this interface is up. Means maybe administrator or admin have run no such command on the interface. And line protocol of this interface is also up. And here it's saying what? Connected. Means the connected device status is also up, right? Both side status is up. That's why we are getting what? Line protocol up. So this Ethernet up or administratively down is indicating what? Indicates whether the interface hardware is currently active or whether it has been down by a admin, or it can be a disable also, right? Sometimes you will see disable, right, in real time. So disable indicate that the interface, switch interface or router interface has received more than 5,000 errors in keep alive interval, which is 10 seconds by default. So in 10 seconds, which is by default keep alive interval, if you will get 5,000 error, right, in keep alive interval, so you will see your interface is disabled. Guys, this is completely real time, right? So maybe if you are not network engineer, you are not getting my point. But if you are network engineer, I'm damn sure you are getting my point, what I'm trying to say, right? So this is status. Second thing is what? This is hardware type. This is what? This is hardware type. Specify the hardware type. And then this is what? This is hardware address. This is hardware address. After that, what information we have? We have information of bandwidth. This is bandwidth of the link. Then we have delay, right? So bandwidth of interface in kilobits per second. Then we have delay. So delay is in microseconds, right? So these are again very important, like delay is in microsecond and bandwidth is in kilobits, right? And then we have MTU. What is MTU? Okay, next information is what? Reliability, right? Reliability is 255 by 255. Guys, reliability is what? Shows reliability of interface as a fraction of 255. 255 divided by 255 is 100% reliable. 255 by 255 means it is 100% reliable. Fine. And you know, this is calculated over 5 minutes. This is output of 5 minutes of last 5 minutes. In the real time here, I think you will get one more option, load, right? I'm not able to see here. Okay. Next information is encapsulation. Encapsulation is ARPA, right? Loopback is not set. Encapsulation specify the encapsulation method assigned to the interface. It is using which encapsulation? ARPA. Then we have what? Loopback. So indicates whether loopback is set or not. So loopback is not set in my scenario. Then we have what? Keep alive. So it is sending one keep alive message after every 10 seconds from this interface. Then next information is what? Duplex. It is working on full duplex. Then speed. Speed is what? 100 Mbps per second. Then what information we have? Input flow control is off. Output flow control is off. Leave it for now. ARP time. Okay, ARP time, what these are basic things. Hope you already know it, right? Last input. What is last input? Last input gives the number of hours, minutes, and second since the last packet was successfully received by the interface. So this interface have last input is 8 seconds, right? So in simple word, what you can say, it indicates hours or minutes and seconds since the last packet was successfully received by interface. This is useful for knowing when a dead interface failed, right? When a dead interface failed. After that, what we have? Last output. So again, last output specify what? It gives the number of again hours, minutes, and second since the last packet was successfully transmitted by the interface. So when last packet was transmitted from this interface, right? Then next information is what, guys? Last clearing. When you have cleared this interface, so it's saying what? Neighbor, right? But here I can run one command, clear counter interface fast ethernet 0/1. So it will show you when you have cleared this interface. Getting my point? So hope till here we have discussed each words very carefully, right? Now next thing is what? Input queue. Right? I'm talking about this guys. Input queue and drop. It gives the number of packets in output and input queue. Each number is followed by a slash, the maximum size of queue, and the number of packets drop due to full queue. So here you can see number of packet size. First one is what? Size, then maximum, then drop. So drop is what? 0 over here, right? So maybe sometime you will get some value over here, right? So if queue is full, because of that, if your interface will drop any frame, it will show you here, right? It will show you here. Then total output drop is 0. Queuing strategy is what? First come, first out. Then output queue. Output queue is similar like input queue, right? Again, it's showing you size and maximum. Then what information we have? 5-minute input rate, 5-minute input rate, or 5-minute output rate. So this gives the average number of bits and packets transmitted per second in the past 5 minutes. What I'm saying? It gives the average number of bits and packets transmitted per second in the past 5 minutes. After that, we have what, guys? Packet input. So how many packet input we have on this interface? 956. So it gives the total number of error-free packet received by the interface. So this interface have received error-free packet. How many error-free packets? 956. Then we have what? Size and 0, no buffer. No buffer means give the number of received packet discarded because there was no buffer space. So 0 means what? This interface have not discarded any frame because of buffer size, because of buffer memory, because of buffer is full, right? Then we have what? Receive broadcast, right? 0 buffer is clear to you. Then received 956 broadcast. What is this? It shows total number of broadcast or multicast packets received by the interface. So this interface have received how many packet on this interface? This one. Then we have what? Runt. Then we have what? Runts. So what is runts? Runts means give the number of packet that are discarded because they are smaller than the minimum size of Ethernet header. As I told you, minimum size of Ethernet header, Ethernet frame should be 64 bytes. So if a device is receiving a frame whose size is less than 64 bytes, you will get runt counter error. Getting my point? So give the number of packets that are discarded because they are, their size is lesser than 64. That is lesser than 64 bytes. Consider as runt. Then next is what? Gints, right? Gives the number of packets that are discarded because they exceeded the medium, or you can say in simple word, gints is nothing but the packet discarded by the interface because their size is greater than 1518 bytes. Because Ethernet frame size can be vary from 64 bytes to 1518 bytes, right? So if an interface is receiving a frame whose size is more than 1518 bytes, it will give you gints counter, error, right? Then we have what? Input error. So what is input error? Include runts, gints, no buffer, CRC, frame, right? It includes runts, gints, no buffer, CRC, frame, overrun, and ignore counts. Other input related error can also cause the input error count to be increased. And some datagram may have more than one error. Let's say here we are getting one CRC error, so you will get one input error as well, right? After that, CRC. Now let's talk about CRC. So CRC indicates that the cyclic redundancy checksum generated by the originating LAN station or device, right, for end device does not match the checksum calculated from the data received, right? As I told you, if machine is calculating CRC value, and if CRC value is not matching, it will give you this counter, this error, right? Okay, then what we have? Then we have frame. So what is frame? It shows the number of packets received incorrectly having a CRC error. What I'm saying? Shows the number of packets received incorrectly having a CRC error. Okay. So again, if you are getting CRC error, you will get frame as well, right? Then what we have? Overrun. We have what? Overrun. So overrun, because generally, these are not important. These are not important counters. Important counters are only these. Only these are important counters. Let me tell you all. Important is first one is runts, right? So here we have 0 runts. So as I told you, when you will get runts error or counter, if frame size is less than 64, then This one is important. Gains. When you will get gains error when size is greater than 1518 bytes, then CRC. When you will get CRC error, as an input is combination of CRC, runs, gains, overrun, ignore, right? CRC is when a device is calculating different CRC value for received data, right? After that, frame. So if format is incorrect, then you will get what? Frame counters. Then we have what? Then we have output error. This is important. Output error. Output error. So when you will get output error, device have tried to transmit the frame, but it was unsuccessful. Then collision is important. If there is collision, then you will get, or in collision, what you can say, it's indicate the number of messages retransmitted due to an Ethernet collision. Due to an Ethernet collision, what we can say, due to an Ethernet collision, gives the number of messages retransmitted due to Ethernet collision. That, you know, messages you will see here in the collision. These are important counters for you, right? And then late collision can be, because of duplex mismatch. Duplex mismatch. So guys, this is type of problem you will get in real time only. And now hope it is clear to you how to troubleshoot. How to troubleshoot. So guys, if this is clear to you, if you have learned something from this video, please hit on like button. If you have not subscribed my channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe guys. Bye bye. That's all for today, right?